Commercial feedlots are cities of livestock. We're talking about tens of thousands of animals, tightly managed across hundreds of acres, where every calorie is calculated. To maintain that scale, operations rely on extreme precision. Nutritionists engineer exact dietary formulations, which are then processed by massive industrial feed mills to ensure absolute consistency across every single batch. This chart shows the financial reality of running an operation like this. When we look at total operating expenses, feed costs absolutely dwarf labor, transport, and medical care combined. It is the single largest investment a producer makes. That expensive, perfectly calibrated ration is then mechanically delivered by specialized trucks, pouring an exact weight of feed into numbered bunks along the pens. All that upstream science, knowing, and precise delivery hits a wall at the physical trough. If the cattle do not consume that ration exactly as it was mixed, the entire multi-million-dollar model breaks down. Managers cannot ask a steer why it skipped breakfast, and guessing the answer, or making assumptions about what they need to eat tomorrow, leads to rapid physical decline and catastrophic financial waste. That makes the physical trough the most honest source of information in the feedlot. It is a historical record of yesterday's behaviors, giving professional managers the physical evidence they need to make accurate nutritional decisions today. This graphic shows a top-down view of a standard feed bunk. A reliable pen normally cleans its ration. Today, a professional feedlot manager will look past the sheer quantity and walk the entire length of that bunk to see how the feed is sitting. If the remaining ration is piled up at one end and bare at the other, the cattle's appetite might be perfectly fine. The feed truck may have a calibration error, or heavy overnight winds might have blown the lighter particles down the line. Or they might look for sorting. Cattle use their noses to dig through a pile, hunting for sweet, high-energy grains and pushing the roughage aside. When they do that, they completely dismantle the nutritionist's carefully planned diet. They consume a highly concentrated, starch-heavy meal and leave the long, fibrous forage behind to rot. Left unmanaged, that creates severe digestive imbalances in the herd. Analyzing the physical condition of the leftovers prevents those downstream disasters. The investigation also has to account for what is happening outside the trough. An overnight rainstorm completely alters the palatability of a ration. Added moisture acts as a rapid accelerant for spoilage, souring the feed and encouraging mold development in a matter of hours. Pests tell a story too. A heavy bird population swarming a trough steals expensive grain, heavily contaminates the area, and transmits disease into the feed. And that brings us to the most vital diagnostic assumption of the feed bunk. It is a biological early warning system. This chart shows the timeline of a typical illness in a feedlot. Notice how the blue line representing feed intake drops aggressively 2 full days before the red line representing visible clinical symptoms actually spikes. The appetite crashes first. A sudden refusal to eat often signals an incoming wave of bovine respiratory disease or severe environmental fatigue like heat stress, which requires rapid intervention to keep the animals cool. To maintain an accurate read on these changes, managers systematically clear out the spoiled leftovers. By tracking these refusals, they reset the pen's baseline for the next delivery cycle. Catching that drop in consumption early allows veterinarians to isolate animals and start treatment days before a steer shows a single physical sign of sickness. Scaling this up, major operations don't leave this diagnostic process to chance. They formalize it, training specialized bunk readers to apply standardized scoring systems across thousands of pens every single morning. It is a rigorous methodology practiced globally, driving efficiency in massive Australian feedlots and establishing critical cost control for rapidly expanding operations in the Philippines. In an era where modern agriculture leans heavily into digital sensors, complex predictive models, and automated data collection, this purely physical process remains stubbornly indispensable. Because ultimately, the most cost-effective tool a manager has isn't a piece of technology. It is the disciplined human observation of yesterday's evidence used to make a smarter decision today.